Today, we're going to pull back the curtain on the invisible architecture that, well, basically runs our entire digital world. We're going to talk about how one really brilliant idea brought order to the absolute chaos of early computing and, in the process, built the foundation for pretty much everything we do online.
So yeah, what do all these things share? The answer is the database. It's this quiet, unsung hero of the modern age. It's the powerful, organized library working tirelessly behind the scenes. And you know, without it, our digital lives would just be a complete and total mess. But it wasn't always this neat and tidy.
Okay, so let's set the scene. I want you to picture the 1960s. Computers are just starting to become these serious tools for business, right? But actually managing the data they were kicking out, that was like trying to navigate a maze in the dark. It was a chaotic and frankly super frustrating challenge.
And this really shows you the core problem back then. Early databases, they forced all your data into these super rigid structures, kind of like a family tree. If you wanted to find, say, a cousin, you'd have to go all the way up to the grandparent and then all the way back down. The network models that came next were a little better, a bit more flexible, but they created these tangled spider webs of connections. So what was the result? The data was just completely trapped by how it was stored. And this right here shows you the central issue, what they call data dependency. Basically, the way you physically stored your data dictated the kinds of questions you could ask about it. Just imagine you filed all your project info under the specific parts they used. Now asking a simple question like, hey, what parts does Project Alpha use, became a total nightmare. You literally have to search every single part in the whole system to see if it was linked to Project Alpha. It was clunky, it was inefficient, and just incredibly complex.
But then along came the hero of our story. An unassuming mathematician working at IBM who saw a simple, really elegant way out of this data labyrinth.
Edgar, or Ted Cod, as his friends called him, he wasn't your typical computer programmer of that time. No, he was an Oxford-trained mathematician, a former pilot in the Royal Air Force, and, a bit of an outsider at IBM. And that unique perspective is what let him see the problem not as an engineering mess, but as a logical puzzle.
And this quote, this is it. This is Cod's revolutionary aha moment. He realized the problem wasn't the data itself. It was the fact that the logical view, that's how a person thinks about the data, was all tangled up with the physical view, which is how the computer actually stores it on disks and tapes. His big idea? Let's build a wall between them.
And his solution was just beautiful and simple. He called it the relational model. Just imagine organizing all your data into simple tables, just like a spreadsheet, right? Each row is its own unique thing, and each column is a detail about that thing. And with this system, the question, show me all employees in the sales department, was now completely separate from how or where the computer was storing that information. The user didn't have to navigate that maze anymore.
So, back in 1970, Cod published his theory. And get this, not as a product, but as an idea, in a research paper. And that idea, all by itself, was powerful enough to kickstart a revolution that honestly defines the world we live in today.
The whole revolution really happened in 3 stages. First, Cod puts out his theory. Then, research labs at places like IBM and Berkeley, they build these experimental systems to prove, hey, this thing can actually work. And out of those projects, a new language was born, SQL, the structured query language. And it pretty quickly became the universal way to talk to any relational database, a standard that, believe it or not, still dominates today.
And once SQL was out there, man, the floodgates just opened. Companies like Oracle and IBM jumped on it, they commercialized the technology, and soon enough, relational databases were everywhere. Those old, rigid models, they became relics, basically museum pieces. Cod himself, he got a little worried that companies were just slapping the word relational on their products as a marketing gimmick. So in 1985, he published his famous 12 rules to define, with mathematical precision, what his model really was.
But, as you know, technology never ever stands still. And the very success of the relational model, which brought all this order to business data, was about to face a brand new kind of chaos.
And then, the internet changed the entire game. Suddenly, we weren't just dealing with neat little employee records and sales figures. No,
We had a tsunami of messy, unstructured data, website clicks, social media posts, photos, videos. This was the start of the big data era, and it brought challenges of scale and variety that Cod's original model just wasn't built for.
This led to a whole new wave of database technology. Now, relational databases are still perfect for things that need to be absolutely 100% consistent, like your bank balance, right? You want that to be right. But these new models, like NoSQL, they were designed for the messy, massive, and super fast-moving data of the web. They prioritize flexibility and scale above all else, which is why they're perfect for things like your social media feed.
So where does that all leave us today? Well, Cod's vision is still right at the heart of our digital economy, but it now lives in this really diverse ecosystem, and it's raising questions that go way beyond just technology.
I mean, today, the market that Cod basically created is this battle of titans. You've got the established powerhouse, Oracle, fighting it out with Microsoft's SQL Server. And then there's the open source champion, MySQL, which powers a huge chunk of the web. So this isn't some legacy tech. Cod's model is still incredibly big business.
But the story really doesn't end with market share. Cod solved the technical problem. How do we organize data? But in doing that, he unleashed a power that has created some really profound societal and ethical questions.
This power to organize data so well brings us face to face with some genuinely tough questions. I mean, think about it. Our most personal information, from our medical histories to our actual genetic code, it's all becoming data. The technology exists to connect it all, which leads to these questions that not too long ago were pure science fiction, like, should a company be able to look at those records when deciding who to hire?
And it's not just about the big, life-altering stuff either. It's the small things, too. Every single click we make, every article we read, every product we look at, it all gets logged in a database somewhere. And that creates this digital trail of our interests, our habits, our curiosities. So the question becomes, who gets permission to follow that trail? Who gets to connect all those dots and build a detailed profile of who you are?
You see, Cod solved the technical problem of how to organize the world's data. But in doing so, he left us with a much, much harder societal problem. He gave us the how, but he didn't give us the who. Who gets to decide the rules for this immense power? Who weighs the incredible benefits of discovery against an individual's right to privacy? This isn't a question for computer scientists anymore. It's a question for all of us.